Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll find the values of dy over dx for the given value of x for these two functions. So let's start with the function on the left side. So this function is made up of two functions that are being multiplied. The first one is 2x plus 1 exponent 5 and then 3x plus 2 exponent 4. So we can use product rule to find the derivative of this function, and as per the product rule, so the derivative is the first function times the derivative of the second function plus the derivative of the first function times the second function. So let's start with our first step. So we will use the Leibniz notation. So dy over dx is equal to, so the first function 2x plus 1 exponent 5 times the derivative of the second function. So for that we'll use the power rule. So the exponent is brought down to the front. So 4 times 3x plus 2 and then exponent 4 minus 1 times the derivative of the inner function 3x plus 2. So that will be 3 plus 0 because the derivative of 2 is 0 because 2 is a constant and the derivative of 3x is just 3 plus now the derivative of the first function, so we'll use the power rule, so we'll move the exponent to the front, so 2x plus 1 and now we'll subtract 1 from 5 and then times the derivative of the inner function, which is 2x plus 1. So the derivative of 2x is just 2 and the derivative of 1 is 0. Then times the second function, 3x plus 2 exponent 4. Now we can sub in the value of x, which is given as -1 in this expression to find the value of dy over dx. So we do not have to simplify it first. We can input the value of x in this next step. So we can do dy over dx equals, so in the first parentheses we do 2 times -1 plus 1 exponent 5 times 4 and then 3 times -1 plus 2 exponent 3. And 3 plus 0 is equal to just 3. And now the next part, so plus 5 and then parentheses 2 times -1 plus 1 and then exponent 4. Now 2 plus 0 is just 2 and then 3 times -1 plus 2 and exponent 4. Now we can simplify this further. So dy over dx equals, so in the first parentheses we get 2 times -1, which is -2, and -2 plus 1 is -1 exponent 5. Then times 4. Now in the other parentheses we do 3 times -1, which is -3 plus 2, which is -1 exponent 3 times 3. Now plus 5. Now in the first parentheses 2 times -1, which is -2, and -2 plus 1 is -1 exponent 4 times 2, and then 3 times -1 is -3, and -3 plus 2 is -1 exponent 4. Now we can simplify this further. So dy over dx equals, so -1 exponent 5 is equal to -1, then times 4, and then -1 exponent 3 is equal to -1 and then times 3 plus, now 5, now -1 exponent 4 is equal to 1. because here we have to multiply negative 1 by itself 4 times 2, and then again negative 1 to the power 4 is just 1. Now we can simplify it further. Equals, now negative 1 times 4 is negative 4, negative 4 times negative 1 is positive 4, and 4 times 3 is 12, plus, now 5 times 1 is 5, 5 times 2 is 10, and 10 times 1 is 10. So therefore, dy over dx is equal to 22. So this should be the final answer for the value of dy over dx for the first function. Now we can analyze the second function. Now the second function is y equals x times 5x minus 2 times 5x plus 2. Now this is a tricky one because in this case we are given three factors. So it's x times 5x minus 2, then 5x plus 2. We can simplify this expression by distributing x into the parentheses, and that will reduce this expression into a two multiple expression. So we'll get y equals 5x squared minus 2x. So I'll just fix it. 5x squared minus 2x times 5x plus 2. Now we can use the product rule to find the derivative now, because we only have two functions that are being multiplied. So the first one is 5x squared minus 2x, and the other one is 5x plus 2. And we have to find dy over dx at x equals 3. So we can start here because we'll need some space. So dy over dx equals, so we'll write the first function 5x squared minus 2x times the derivative of the second function, which is 5 plus 0, because the derivative of 5x is just 5 and the derivative of 2 is 0 because 2 is a constant, plus now the derivative of the first function, and that will be 10x minus 2 times the second function 5x plus 2. So this is the derivative expression. Now we can sub in x as 3 because we can find the value of dy over dx from this expression. So we get dy over dx equals, parentheses, 5 times 3 square minus 2 times 3. Now in the second parentheses, so 5 plus 0 is just 5, plus, now in the second part, so we do 10 times 3 minus 2, and then 5 times 3 plus 2. Now we can simplify this expression. So dy over dx equals, so in the first parentheses we get 5 times 9, because 3 squared is equal to 9, then minus 2 times 3, which is 6 times 5, now plus, now we do 10 times 3, which is 30, and 30 minus 2 is 28, and then times 5 times 3, which is 15, and 15 plus 2 is 17. Now in the next step we can simplify this expression further. So we get dy over dx equals, so 5 times 9 is 45, and 45 minus 6 is 39. So 39 times 5 plus, and now we can do 28 times 17, which is equal to 476. Now in the next step, we can multiply 39 and 5. So we can do here. So dy over dx. So 39 times 5 is equal to 195 plus 476. And now we can add these numbers. So 195 plus 476 is equal to 671. So this should be the final answer for the value of dy over dx for this function at x equals 3. So these are the steps you have to keep in mind to solve a problem like this one. So we start by finding the derivative of the given function, and for a function like the second one, we have to distribute the x into the parentheses to change this function from a 3-factor function to a 2-factor function, because then we can use product rule, so it becomes easier to find the derivative of the function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.